Hello guys, welcome back to VC Tech. Have you ever wondered how the internet actually works? How networks in different countries using different ISPs or internet service providers are still able to communicate with each other? Today we are talking about BGP, Border Gateway Protocol, the routing protocol that connects the world together. By the end of this video, you will understand what BGP is and why it is different from OSPF and RIP, and where it is used in a real-world network. So before we get into the configuration, let's have a bit of a knowledge of what BGP means and how it works. BGP stands for Border Gateway Protocol. It is a path vector routing protocol used to exchange routes between different networks. This is very important, guys. Take note of this. It also uses an autonomous system number, also this one. And BGP is known as the routing protocol of the internet. So the difference between BGP and interior routing protocols, which are OSPF, RIP, and EIGRP, all these interior routing protocol work inside one organization. However, BGP works between different organizations. OSPF uses host, RIP uses hop count to determine the path. BGP uses policy-based routing, meaning it selects routes based on the rules that we define, and those rules are enforced using tools like prefix lists and route maps. Now, BGP can do a lot more than just exchange routes. Things like prefix lists and route maps let you control which routes are advertised and how they are treated. However, if you would like a separate video on that, let me know in the comment section. BGP focuses on stability and control. Where BGP is used: Internet service providers or ISPs, large enterprise network with multiple locations, data center and cloud providers, banks, telecoms, and global companies. Any company connected to the internet uses BGP. How BGP works is it uses TCP port of 179. It also forms neighbor relationship. It advertises reachable networks, and it chooses best paths using attributes. It is also designed for scalability and reliability. So with that being said, let's head over to the configuration phase and see how we configure BGP on a router. For this tutorial, we have 3 routers, 2 switches, and 4 host PCs. And as you can also see, we talked about BGP BGP uses an autonomous system number, which we have 20 for this local area network. We'll be using autonomous system number of 20 for this local area network, and 50 for this local area network, and also 30 for this local area network. I'm going to say something briefly before we get into the configuration. BGP is an exterior routing gateway protocol that is used to route between different organizations, while OSPF, RIP, and EIGRP are used to route within an organization. Now, with that being said, let's head over and start our configuration on the router. How do we configure BGP? We say router BGP, then we specify the autonomous system number. For this router, we'll be using 20, and we also want to specify the router ID. So we say BGP router ID. We'll be giving this router 1.1.1.1. And after doing that, BGP also advertises the neighbor network. Now, the neighbor network to this router over here is this router. So we say neighbor, then the IP address of the next hub. The IP address on the next hub is interface gig 0/0 on this router, which is 10.10.10.2. So we are going to specify that here, which is 10.10.10.2. with remote AS number of 50. So we are using the remote AS number of this router over here because they are going to be forming neighbors. So the neighbor router is 10.10.10.2 with remote AS number of 50. And we are also going to specify all the networks that are directly connected to that router, which is the networks are 10.10.10.0 network, which you specify the mask, a subnet mask of 255.255.255.0. Let's also specify the IP of this local area network, which is 192.168.1.0 with the mask of 255.255.255.0. Now on this router we've configured BGP. Let's also do the same for this router and this router over here to enable the host devices on the different organization communicate. So we do router BGP with an autonomous system number of 50. We also specify the BGP router ID, which will be taking 1.1.1.3. Guys, you can assign any BGP router ID that you want. For this tutorial, we are going to be using 1.1.1.3 and 1.1.1 or 1.1.2. So next we have to specify the neighbor router. Now, how many neighbor router is this router connected to? Is 2. This one over here and this one over here. So 10.10.10.1 with a remote AS number of 20, which is the autonomous system number of this router over here. And if you watch closely, it has formed neighbor with this router over here. It means these devices in this organization can be able to ping this router over here, the BGP router. Now let's also specify the second neighbor, which is neighbor that will be taking the IP address of 10.10.20.1, sorry, 20.1, because it uses the next hub IP. The neighbor is always the next hub IP, 20.1, with remote AS number of 30. That has a remote AS number of 30, so 30. And after doing this, let's also specify the networks that are directly connected, which is 10.10.10.0 with a mask of 255.255.255.0. Let's also do the same for the second network, 10.10.20.0 with a mask of 255.255.255.0. So by doing this, we've configured BGP on this router to enable this device over here to communicate with this device over here. Now let's configure BGP on the last router and let's try to ping. So router BGP with an autonomous system number of 30. We also want to specify the BGP router ID. This will be taking 1.1.1.2. And we want to specify the neighbor that is directly connected, which is 10.10.20.2 with remote autonomous system number of 50. And as you can also see, guys, it has formed neighbor with this router. As if we check, we are going to see that 1.1.1.3 router has formed neighbor with 1.1.2. Let's also specify the networks that are directly connected on this router. So 192.168.2.0 network with a mask of 255.255.255.0 and a network of 10.10.20.0 with a mask of 255.255.255.0. Guys, we've configured BGP on all three routers. We've configured BGP here, and this router has the router ID of 1.1.1.1. This router also has the router ID of 1.3, and this router has the router ID of 1.2. Remember guys, BGP is an exterior routing protocol. It is used to route between different organizations in different locations. As you can see, I have here the US, and I also have India for this organization, and I have US for this organization. That is the work of BGP. It is used to route between different organizations regardless of what their interior routing protocol is. They could be using OSPF as their interior routing protocol. However, for this organization to communicate with this organization over here, there has to be a configuration of BGP to enable communication between the both organizations. So that is the work of BGP. Let's assign IP address to the host devices and try to ping and see if we are able to communicate with both organizations. So we assign the default gateway of 1.1, and let's also do the same for this local area network. .2.5, and let's assign the default gateway of 2.1. Then let's try to ping from the organization in India to the organization in the United States. So 192.168.1.5. As you can see guys, we are able to communicate from this organization in the US to the organization in India. Guys, from the configuration we just did, this router over here is the router enabling this organization to communicate with this organization over here. Without BGP configured on the routers, they cannot communicate regardless if we have our interior routing gateway protocol configured on the router. Without BGP, this organization cannot communicate with this organization, as if we are assuming this organization in the US is using an interior routing protocol of RIP, and this organization in India is using an interior routing protocol of OSPF, those two organizations cannot communicate. But with the help of BGP, they can communicate, because BGP is used to route between organizations. Now we can check for a BGP summary on the router. So let's troubleshoot. We can say do show IP BGP summary. So by doing this, it is telling us that on our router, on our local router, our autonomous system number is 50, and this is our router ID, as well as we have neighbor of 10.10.10.1 and 10.10.20.1, and they also have an autonomous system number of 20 and autonomous system number of 30. As if we do that on the routers, as if we do that on the router in a different organization, we are also going to see the neighbors that are connected to it. So we say do show IP BGP summary. We can also see that for this router we have an autonomous system number of 20 and our router ID is 1.1.1. We also have a neighbor of 10.10.10.2 with an autonomous system number of 50. Guys, this is how BGP is being configured on a router to enable organizations that uses different interior routing protocol to communicate on the internet, because BGP is an exterior routing gateway protocol. It is used on the internet for us to communicate with other organizations in different locations. If this video helped you understand how BGP works for different organizations, then you will be amazed what prefix list and route map could do. However, on the next video, we'll be talking about access control list. If you've not subscribed to this channel, what are you waiting for? Subscribe, like, and leave a comment, because in the next video, we'll be talking about something even more interesting. Thank you guys, and see you in the next video.